Now we will learn about the hyperconjugation effect. Hyperconjugation affects so many ways, and there are lots of effects. One by one we will learn. First of all, we will learn the stability of unsaturated hydrocarbon. As the hyperconjugation increases, stability of unsaturated hydrocarbon increases. This is unsaturated, and this is also unsaturated. This has a three hyperconjugate hydrogens, three hydrogens L alpha positions. It can show three contributing structures. One will be aliphatic structures, and this will show 1 2 3 hydrogens, 4 hydrogens, 5 6. This is alpha positions, this is also alpha positions. The condition is satisfying the for being a hyperconjugation to show hyperconjugation condition is satisfying. It is unsaturation alpha positions. Carbon also has a hydrogens. This is a 3 hydrogens, this is 6 hydrogens. So this has a more number of hyperconjugating structures increases. As the hyperconjugating structures increases, stability of unsaturation increases. So already whatever text I have written, the same things. The R2C means 2 methyl group, 2 methyl group, 2 2 2 1 methyl group, 1 1 methyl group, 1 0 0 0 methyl group. So this increasing order of the stability in hyperconjugation is shown. As in this example, there is unsaturated system, 2 hydrogens at alpha positions, 3 6 hydrogens, 2 hydrogens. So it has more hyperconjugation, so it will increase the stability of a compounds. Now in the relative stability of carbocation, as the alpha carbon increases the hydrogens, the stability of carbocation increases. This has a 3, this carbocations has a 3 methyl group. This is a 1 methyl group, 2 methyl group, 3 methyl group. This 3 methyl group, this is a 3 hydrogens, 3 hydrogens, 3 hydrogens, total 9 hydrogens. So as the hydrogens increases, hyperconjugating structure increases, stability increases. So this is a 3 6 9 hydrogens, 6 hydrogens, 3 hydrogens, no hydrogens. So this is a 9 6 3. As the hydrogens increases, stability increases. So this is the structure is drawn. This thing I have already explained how the hyperconjugation is happening. This shift to this minus plus will form a bond, this become a plus. Similarly this happen, and similarly this thing happen. There is a total 3 contributing structure, 1 aliphatic structure, to total 4 hyperconjugating structures. In this way, this is stabilizing the carbocation. This is the I effect. By the I effect also stabilizing, and this is a hyperconjugation, so also stabilizing the compound. Reaction intermediate, this is a carbocation as a reaction intermediate. So number of hydrogens, this is a 3 hydrogens, 3 3 6 hydrogen, 3 3 6 hydrogen, 3 3 9 hydrogens, 9 3 6. As the hydrogens increases, hyperconjugations increases, and the stability increases. Tertiary carbocation is more stable than secondary than the primary. This is a free radical also intermediate. So this is a 9 3 3 6 9 3 3 6 3. As the hydrogens increases, stability increases. So tertiary free radical is more stable than the secondary than the primary. The same thing is written. This is 3 3 6 9 hydrogens, 6 hydrogens, 3 hydrogens, no hydrogens. This is 3 hydrogens, 3 3 6 hydrogens, and 9 hydrogens. As the hydrogens increase, hyperconjugating increases, the stability increases. This is the shown the structure how this are stabilizing the free radicals. How the structure form, this will shift 1 electrons, this will shift 1 electrons, this 1 electron will form a bonds, this become a free radical. Similarly this happen, all the things similarly happening. Dipole moment, as the dipole moment increases by the hyperconjugation, because hyperconjugation introduces polarity in the molecule. By this there is a minus, because this become minus, this become plus. So this is a polarity is produced. This has no polarity, but due to hyperconjugation polarity increases. The polarity increases, dipole moment increases. This has a 2.27 dipole moment, this has a 2.72. So dipole moment increases, polarity increases, dipole moment increases. Bond length, as the dipole moment increases, bond length decreases. So for normal any compound, suppose this is any compound, this bond length should be 1.54. This bond length should be 1.54 for any compounds which has a double bond. This double bond has a length 3.53 angstrom. This is not angstrom, but due to hyperconjugation, this single bonds sometimes become double bonds, this double bonds become sometimes single bond. So both the bonds have the same bond length. This single bond should be length 1.54, but due to this it becomes sometimes double bonds, so sometimes become single bonds. So see, now this is a single bond, so it become double bonds, so it will decrease the size of this distance of this bonds, bond length distance decreases. This become 1.46, this become 1.46, but actually for single bond 1.54 angstrom should be the length, but due to hyperconjugation it will become double bond, so this bonds become 1.46. This single double bond should be 1.353, but due to hyperconjugations this become also 1.46 angstrom. Due to it becomes sometimes double, sometimes single changes, that's why it become 1.46 angstrom. So the bond length is also affected by the hyperconjugation. Orientation effect of electrophilic substitution reaction on the benzene ring. As the hyperconjugations increase the electron density at the ortho position and at the para positions, due to hyperconjugation this become a sometime minus, this is minus. So this minus position generally come due to hyperconjugation. If we draw hyperconjugation, the minus will charge come to this position. This is ortho, this is a para. Ortho, para. This is a ortho position, this is a para position. This is a, actually this is a ortho position, this is a para position, this is a meta positions. So ortho position and meta positions. This ortho and meta here is written with at ortho positions and para, ortho, meta, para. Actually it is written wrong. Ortho and meta position. At the ortho and meta positions the electron density increases, that's why these two are very susceptible to attack by the electrophile. Electrophile are the electron deficient, so it will attract the electron rich atoms. So this is ortho positions has a more minus charge, that's why this is a ortho and meta. This is a ortho, para, meta positions. Ortho and meta positions are very susceptible to the attack of electrophile because this is electron rich due to the hyperconjugations. Now anomeric effect. Anomeric effect may be defined as tendency of anomeric substitutions to prefer axial configuration over the equilateral. Due to axial positions are more occupied due to the anomeric effect, means there is hyperconjugation in the axial configuration over the equilateral positions. This is not much important, but for the understanding purpose I am written there only 2-3 lines. The high stability of alpha methyl glucoside compared to beta ionomer can be explained by using hyperconjugation. When we will learn the bimolecules, then we can get to know that hyperconjugation increases the stability of alpha methyl glucoside compared to beta ionomer. In the bimolecule I will explain all the things. As the alpha ionomer can also hyperconjugation of lone pair of oxygens atom with the axial methyl group, which is not possible with the beta ionomer due to equilateral positions. So this is not only 2-3 line need to be know. This is not much important. Now we learn the type of hyperconjugations.